Now let's look at how we can use this unit circle. Here I've got several examples of different unit circles where we're looking at values in different quadrants. Now just before we move on to this, we're talking about unit circles, so we know that our opposite side would be sine of theta, and we know that our adjacent side would be cosine of theta. Something that we haven't talked about so far is how we work out tan of an angle. Now tan of an angle is always the opposite side divided by the adjacent side. So in this case, the opposite is sine theta and the adjacent is cosine of theta. We will look at this in more detail later, but it's important that we remember that tan of theta is sine theta divided by cosine theta. Now, why are we doing this? Well, for this reason. In the first quadrant, the value of sine is positive, the value of cosine is positive. If I've got a positive divided by a positive, it would also mean that the value of tan is positive. So all of my trigonometric ratios in this quadrant are positive. Now let's move on to the second quadrant. In the second quadrant, my value of sine is positive, my value of cosine is negative. If sine is positive and cosine is negative, it will also mean that tan is negative. So the only positive value in the second quadrant is sine. In the third quadrant, cosine is negative and sine is negative. Well, if I do a negative divided by a negative, it gives me a positive value. So the only trigonometric ratio that's positive in the third quadrant is tangent. And then in the fourth quadrant, we have cosine as positive, sine as negative, and again, negative divided by positive will give me a negative. So the only value that is positive in my fourth quadrant is cosine. Now this is sometimes referred to as cast, and it lets you know which of the trigonometric ratios is positive in which quadrant. We'll come on to use this later in this tutorial. We discussed previously that sine of 50 will have two values. It will have a value here, and it will also have a value on the other side. We can see that sine of 130 has the same value as sine of 50. And again, if I draw on a little extra in here, angles on a straight line add up to 180. The missing angle here would be 50. So this is exactly why sine of 50 is equal to sine of 130, because that height above the x-axis is the same for both of those angles. Now let's go back and think about flipping the other direction. So this time I'm going from above my axis to below my axis. But again, notice that the angle in here, if this is 310 degrees around the outside, that this angle here will be 50 degrees. So this distance, the magnitude, is the same as the magnitude here. So the size of sine 50 is the same as the size of sine 310. It's just that in this quadrant, the value is negative. So we would say here that sine of 310 is equal to minus sine of 50. And again, remembering back to cast, sine is only positive in the first and second quadrant, where all of them are positive and sine is positive. So when we get round to here, the value of sine will be negative. Now let's see how we can use this unit circle to evaluate certain situations. So we're going to be able to do these without using a calculator, and the first thing we do is we draw a diagram. So here's my unit circle. I'm measuring 450 degrees, so from my start point I'm going round through 360 degrees, and then I need to go on a further 90 degrees. So I would end up with this situation, and if I've gone on a further 90 degrees, I'm looking at sine of 90. Well, that's the maximum value that sine can take, so the value of sine 450 is 1. Cosine of negative 540. Well, where I've got a negative angle, instead of measuring anti-clockwise, now I'm measuring clockwise, so I still start from 0. I'm now just wrapping round through minus 360 degrees, and then minus another 180 degrees takes me to this point here. So I'm looking at the value of cosine at this point here. Well, that's the minimum value of cosine, so this value here is negative 1. Let's now look at tan of 495. So again, I start from 0. This time I'm measuring anti-clockwise. So we go round through 360 degrees, and then I'm going to need to go round through a further 135 degrees. So I'd get to this point here, 135. Now, I know that the acute angle here is going to be 45 because angles on a straight line sum to 180. If this is 45 degrees, what I've got here is a nice little isosceles triangle. So sine and cosine are going to have the same magnitude, but remember, in this quadrant, sine is positive, cosine is negative. So I would have a positive value divided by a negative value, or rather the same value. So this would be sine 45 divided by negative cosine 45, but we know that these are both the same thing. So what we have here is minus 1. In the final example, we're going to look at how we can express trigonometric ratios as acute angles. So again, we start from a diagram. Sine of 150 degrees. Well, let's start by mapping that out. 0 round to 150 degrees. I want to map this as an acute angle, so I need the acute angle underneath, which is going to be 30 degrees. So sine of 150 is the same as sine of 30 degrees. Now I should just check that the signs marry up, and by signs I mean positives and negatives this time, and we do that again by thinking about cast. Now in this second quadrant, sine is positive, so sine of 150 is the same as sine of 30. Cosine 240, so again I start from 0, I'm measuring round through 240 degrees, that takes me to this point here, so that's 240. I want that as an acute angle, so that then means that I think past 180 I've gone 60 degrees. And I'm thinking here about cosine. So this is going to be the same as cosine of 60. But here, remember, cosine will be negative. So cosine 240 is the same as minus cosine of 60. And again, we can think about this in terms of cast, because we know the only trigonometric ratio that's positive in the third quadrant will be tangent. Lastly, let's look at tan of minus 100. So tan of minus 100, again mapped through, is going to take us this way. The acute angle that I'm looking at this time is going to be 80 degrees. So tan of minus 100 is the same as tan of 80. And again, I look for my cast diagram. In the third quadrant, I know that tan is positive, so tan of minus 100 is the same as tan of 80. I don't need to make a sign change this time.